Hi guys, in the previous video on k-means, we saw how k-means clustering algorithm helps us create clusters. So we use this piece of program to create two clusters. Now we will go through each logical unit of this program to see how it is generating two clusters. Okay, just let us copy this here. This is point number one. Create a data set, randomly select two data points from this data set, and consider those data points to be initial two centroids. Correct? Fine. So we are creating data for x-axis. This is for y-axis, and we are creating data frame out of that. And we are also creating one column by the name group and making it 0 initially. So all the data points will be initially considered to be belonging to one cluster. Eventually, they will be belonging to two clusters, two different clusters. So fine. So let us run these three lines or four lines, okay, and just see how our data frame will look. This is how it looks. Next line is very important. Okay, this we are creating two centroids with the help of randomly selected two records from this data set. See, when we run this, this is how it will be. And it is showing us indexes coming out of our data set. So we have to remove them and make it 0 and 1. What we can do, we can say reset index drop true, and then it will do that work for us. Great. So done. Everything is done. So what we will do, let us remove this. This is anyway happening here, right? This is anyway happening here. And last but not the least is draw a scatter plot for this data. What? D of x, D of y. That is scatter plot for data set, scatter plot for those two centroids. Run it. This is how it looks. Great. So point number one taken care of, and we will remove this so that this place is not looking crowded. Point number two, calculate distance between all data points and centroid number one. B, all data points and centroid number two. Let the calculated value decide the proximity to either of these centroids for each data point. Good. So we will do this. Okay. What we will do, we will bring in this piece. This is what it is doing. This will decide about the proximity. Okay. Fine. Good. Those lines are required. See, if need be, we will run each one of them separately. See what this is doing? This first line. It is calculating distance between all the data points and centroid number 1. Second line. Here we are calculating distances between all the data points and centroid number 2. Okay, done. Distance calculation is over. After having created these two variables, we will create two columns in our data frame and attach this series to this column and attach this series to this column. After doing that, we will decide which data point is closer to which centroid, and this command is doing that. Okay, sorry, I press some. Okay, so this will be done by this command. Let us run this whole stuff and we will discuss. And run df. See, this series we attach, right? Centroid distance. This data points distance from centroid 1 is this value, and from centroid 2 is this value, and we can consider any unit. Okay, and look at this. Is it closer to centroid 1 or centroid 2? It is closer to centroid 2 because the value is lesser than this value. Hence, group is 1. Wherever data points are closer to this, it will be 0. Right? So we have created two groups. If any data point happens to be closer to this, that will belong to group number 0. And any data point happens to be closer to this column or centroid 2, group will be 1. Done. So all the things we have done. Correct? And just see this command. NP where this centroid less than equal to centroid 2, centroid 1 less than equal to centroid 2, then it is 0, else it is 1, and that is what we have done. So this entire piece is also done. Correct? Let us remove this from here. Point number 3, calculate the group-wise average for all the data points to reposition their respective centroids. This is very critical. See, initially we already considered centroids positions arbitrarily. Now we will calculate and decide its first position after having calculated distance like this. So bring that relevant piece. So here we go. This is what it is. Just one piece, one line. Let me remove this and run this. What is happening? There are two groups. Group number 1 is 0, group number 2 is 1. On the basis of that grouping, entire x and y's average of all the x and all the y's have been calculated, and we have this average. Now our centroids will be positioned at this value. This will be the value for x-axis, and this will be value for y-axis for centroid number 1, and this will be x-axis for centroid 2, and this will be this value will be considered for y-axis so far as centroid 2 is concerned. Okay, good. So we have done that as well. So what is left now? See, 4. Point number 2 and 3 will iterate. We will go here, come here, go there, come here. So we will keep doing 2 and 3. But whenever we talk about iteration, we have to also talk about when that iteration is going to end. When will it end? The moment the repositioning is not happening, which means whenever we are calculating the values for centroids, we are holding them back. So we call it as centroid old, and we are calculating new. And then we are comparing if the new calculated value is exactly as per old, which means what? The centroid positions are final and we should get out of the loop. So when see centroids old is equal to centroid, that is a new calculation, break, loop is over. So this is what this program is doing. Now let us run this and see, right, this entire thing. So we have covered all the 4 points. The fourth is nothing but It is telling do 2 and 3 and get out of the loop when you need not require to be inside the loop. You come out of the loop. Okay. So, okay, let's run this. Okay. Just see. Finally, our centroids, they are not changing any position, right? This and this remains. And so look at the value. 23.8, 23.8, 38.25, 38.25, 25.49, that is for centroid 2, 25.49, 13.6, 13.6, done. If you want to see another piece of clustering, then we can do that. Let us change the value here. We can make it 50,000 and make it 250, 250. Let us run it. It will take some time. Okay. Just see. We cannot eyeball the difference between the previous graph and the current graph sometimes. But we can always look at these values to determine the difference between this and this when we cannot really eyeball clearly. Okay, that is why these are being printed. Okay, so here there was a difference, right? 187.05 and 187.03. Anywhere there is a difference, we will continue. And here you will see that there will not be any difference. Okay, it is still running. So let it run. It will take some time. Okay, it's still difference. So long as difference is there, it will keep running. Check. Can we see the difference? No. Oh yeah, 77, 76. It will run. Now, oh, let us check. Let us check. Let us check. Yeah, 35, 36. It goes on. Let us wait patiently. Yeah, here we are. Everything 187.05, 187.05, 62.6, 62.6, 123.73, 123.73, 126.38, 126.38. It is no more changing now. We came out of the loop, which means our clusters, two clusters have been created. Okay. So this is all about this program. It has created two clusters. We will see how we can create more than two clusters. We will also see how many number of clusters will be the optimum number of clusters for any given data set. Thank you so much for watching, and I will see you in the upcoming video.